Alright, hello BIO100. In this video I'm going to give some additional tips and practice with some things we did in the online lecture part of this week, and hopefully that will help you with the lab activity this week, which is very similar and will build on what we did. So in this video in particular, I will give you some tips for writing a hypothesis, so what that should look like, and also how to identify variables given a certain research question. Okay, so first of all, let's start with the hypothesis. So a hypothesis is written as a testable prediction. So what that means is you're being specific in terms of you're making an actual prediction that can be tested to determine whether your hypothesis is correct or not. So really a hypothesis has to be specific. So let's start with this first bullet point here. Say you are interested in studying whether the number of C. stigmaeus eggs, so that's a flatfish that's shown here. Remember I talked about in the last video, I got all excited about how they start with their eyes on each side of their head, and then as they get older it migrates to the top of their head. Anyways, so this is a flatfish. So that's what C. stigmaeus is. So we're interested in studying whether the number of eggs for that particular species that are collected differs depending on the water temperature. And in this case, we're specifying that the water temperature, we're breaking it up either above or below a mean temperature of 17.8 degrees C. So this is a very similar scenario to when we did the ANOVA lab in previous weeks, same situation. So what I want us to think about is what would a hypothesis be for this particular study. So I'll give you some time to think about this on your own. So here's the overall research question here. How would you phrase that as an actual hypothesis? All right, so a hypothesis might look something like this. You might say something like, I hypothesize that more C. stigmaeus eggs will be collected when the water temperature is below the mean. So you're making, again, a specific testable prediction. So you're hypothesizing that there will be more eggs when water temperature is below the mean. So you're basically picking a side, so to speak, of what you think is going to happen, and then when you gather your data and analyze it, you can determine whether that hypothesis is correct or not. So when you're writing a hypothesis, it needs to be written as this testable prediction. So now let's move on to getting some practice with identifying variables given a certain research question and scenario. So we'll do 3 of these similar types of practices in this video. So here's the scenario here, that first bullet point. So we'll use the same scenario we just used. So you are interested in studying whether the number of eggs collected differs depending on the water temperature. And again, we're specifying above or below the mean temperature is how we're going to be looking at the water temperature. So what I want you to do is think about what is the independent variable for this data set, and is it categorical or continuous? What is the dependent variable? Is it categorical or continuous? And what statistical test would you use to analyze your data? So again, I'll give you some time to think about that first on your own while I sit here and stare at my computer quietly. Okay, let's start with the independent variable. So in this case, the independent variable would be the water temperature. So that's the thing we're trying to figure out if that affects our dependent variable. And we'll get to that in the next part. So in this case, we are using water temperature as our independent variable. And in this case, our water temperature is considered categorical. And that's because of the way that it's stated in this overall research question. So we've specified that we're going to be breaking up water temperature into above and below the mean. That's essentially breaking it into 2 different categories. So for us, in this particular case, the independent variable is water temperature, and it's categorical. What about for our dependent variable? For the dependent variable, that would be the number of eggs collected. So we're trying to see if the water temperature affects the number of eggs collected. So the number of eggs collected would be the dependent variable. And in this case, since we're counting number of eggs, that's a continuous variable. Usually numbers are considered continuous, but of course, as we just said, if you specify you're breaking it into different groups, then it can be categorical. Okay, and then lastly, what type of statistical test would we use to analyze our data? Let's move my head out of the way. I can be on top of the flatfish. So in this case, we would use a t-test because what we're doing is comparing two different groups. So we just said, remember that water temperature is our independent variable and it's categorical. And here we're breaking that up into two different groups, either above or below the mean. So what we're trying to do is see if the number of eggs above is significantly different from below the mean. We're comparing two different groups, so we would use a t-test. Let's move on to the second practice scenario. And here it's very similar. We're still looking at the number of eggs collected, whether that differs depending on the water temperature. But now if you note, this part here is different. Now we've said we're going to specifically investigate water temperature below 10 degrees C, between 10 and 17.8 degrees C, or above 17.8 degrees C. So again, I'll give you some time here to think about what is the independent variable, dependent variable, whether each of those are categorical or continuous, and in this case, what statistical tests you would use to analyze your data. Okay, if you're still thinking, you can pause the video, but I'll go ahead and go through this now. So let's start with our independent variable. Again, the water temperature is our independent variable. It is also still considered categorical because we are breaking it up into these distinct groups of different temperatures. What about our dependent variable? Our dependent variable is also still the number of eggs collected. It is still considered continuous because we're not specifying how we're going to categorize those eggs. We're just counting the number of eggs, so that's a continuous variable. What about this part? What statistical tests would you use to analyze your data? What we want to think about here is how many groups we're comparing, right? So if we pick the statistical test here, we want to use a one-way ANOVA. And that's because we're looking at the effect of one variable, in this case water temperature, and we're comparing three different groups of that independent variable. So remember here we specified we're breaking up water temperature into three different groups or three different categories: below 10 degrees C, between 10 and 17.8, or above. So in this case, because we have three groups of one independent variable, that would be a one-way ANOVA. And for our last practice scenario here, so now we are interested in studying whether the number of eggs collected is significantly related to the water temperature. So same thing here, go ahead and think about your independent variable, dependent variable, whether they're continuous or categorical, and in this scenario, what statistical tests you would use to analyze your data. All right, again, if you're not quite done, you can pause the video, but I'll go ahead and go through this now. For our independent variable, again, our independent variable is still water temperature, but now that variable is continuous. And that's because if you look at the way this research question was phrased, we were just looking to see if it's significantly related to the water temperature, but we're not specifying that we're breaking up that water temperature into different groups. Water temperature is a number, and so if we're not specifying how we're going to divide up those temperatures, it is considered a continuous variable. So in this case, because of the way the research question is stated, our independent variable is water temperature, and it's considered continuous. What about for our dependent variable? That is also the same that it has been for the previous two examples. We're still looking at the number of eggs collected, and that is also still considered a continuous variable. Okay, so what about the statistical test we would want to use? So we have, in this case, it's different. Before we had one categorical variable and one continuous variable. Here, both of our variables are continuous, so what type of statistical test would we want to use to compare two continuous variables? For that, you would need to use a linear regression. So that's where you would create a scatter plot like we did in the modules previously, and you could see if the relationship is significant among those two variables by conducting a linear regression. You can calculate an R-squared value and get a p-value. So that is the different examples I wanted to walk through. Hopefully that gives you some better insight into how you should be thinking about these when you're coming up with your own research question and identifying the variables. But of course, if you still have questions, let me know.